In this video, we're going to start to think about what is a gas. And so this series of videos is really going to talk about the ideal gas law, what it means, how it works. But in order to predict how a gas is going to behave, we should be able to answer a really simple question. What is a gas? What makes something a gas? What makes it not a gas? So gases spontaneously fill any container. If you have a giant jar of gas, so if you have a tank here with a valve, this container is frankly filled with any gas you have. So this whole container is full of gas. And so if you had more than one gas in your container, we have the similar container. In this case, we're going to have part blue or red. And what we see is that it's a full mixture. This is different than like two solids where you could easily phase separate those, a solid and a liquid, or even in some cases, two liquids. Some liquids are easily separable based on their density. But gases spontaneously fill the container and they're really homogeneous. So they are one mixture. So some gases are a vapor. And that means when we have water vapor, it's basically that the water has gone into the gaseous phase, typically in the presence of a liquid. And gases are compressible. We can condense the volume of this structure right here to go from the same size container and basically put all of the gas down here in the bottom. And so when we do that, we're going to change the pressure of the system, which we'll see in later videos. But all of these gases are compressible. And so as we think about the compression of a gas, we can start to think about the pressure. So the pressure is the force divided by the area. And so we are not often going to determine the pressure just from force divided by area calculations, although we could. Mostly we are going to look at different units of pressure and convert between those. So different scientists use different units of pressure. So some different units are millimeters of mercury, atmospheres, torr, Pascal. So how was pressure originally determined? So the first thing is that we had Torricelli, who used mercury. So mercury is a metal, but it is a liquid at room temperature and standard pressure. So he inverted a long glass tube, and what they saw was that the mercury in the system would basically be pushed up to a standard value. And so the mercury in the system is pushed up by the atmospheric pressure. And what they noted was that this value was roughly 760 millimeters of mercury. And so they determined that that unit would be 760 torr. So what we see here is that this barometer, which typically barometers no longer use mercury or they are a closed system. And so what we can use is this original barometer as a standard value. So down here in the bottom, these are some of the standard units. And so basically this is similar to 12 feet. 12 inches are in a foot, or how many feet are in a mile. It's a standard unit conversion. And so all of these are provided in standard values. So let's look at some examples. Road bike tires are aired up to 88.6 pounds per square inch. What is this in atmospheres? So on the previous slide or on an equation sheet, you can see that 1 atmosphere is equal to 14.7 psi. And so we're going to take our 88.6 psi. We want to convert to atmospheres. So for every 1 atmosphere, there are 14.7 psi. When you plug this in, what you should see is that there are 603 atmospheres of pressure inside this road bike tire. And so we can now do a similar conversion, but for a different value. So scientists have measured the atmospheric pressure inside a tornado to be 821 millibar. What is this in torr and what is this in atmospheres? So we're going to take our 821 millibar. And we need to convert that first to bar. So there are 1,000 millibar in 1 bar. And there are 1.01325 bar and 760 torr. And so this gives us 616 torr. And now we're also going to convert that into atmospheres. So we're going to take our 616 torr, and there are 760 torr in 1 atmosphere, which gives us a pressure of 0.811 atmosphere. With pressure conversions, it's very simple for us to change between different values. We can just use a standard value that you'll find on an equation sheet in order to convert between these. So pressure is how we measure gases, and pressure can be converted to different units.